Hello everyone, John here from rchelicopterfun.com. This is a complete junk show, and it's a rather technical video where I'm actually asking for some help or some input from anyone else who might have been through this same situation. I'm just going to go over the background really quickly. Anyone who's been watching my channel lately or maybe have seen on my website, I'm in the process this winter of converting my entire fleet over from my JR X9503 to, I've gone to the FR Sky or Free Sky system. Really like the Horus X12S. All my bigger birds I've converted over no problem using the FR Sky receivers. Okay, all my blade, little bind and fly stuff, and even a couple of airplanes converted over no problem. I should mention that I'm flying all my bind and fly blade stuff and any Spektrum stuff using the Spektrum DM9 module, which is in the Horus. No problems whatsoever. The showstopper for me has been this little T-Rex 150X, and for the life of me I cannot get this thing to work. I'm getting the receivers to bind, but they will not communicate with the 150 GRS. The way I can tell that is when you use the T-Rex 150 GRS app, when you go into the transmitter page, it'll show the channels moving. It works fine with my JR. It doesn't work with the DM9 module. I'm going to show a few things. First off, though, I'm going to link to a really great article from Spektrum's site. It's a PDF that you can download, and it's titled Specifications for Spektrum Remote Receiver Interfacing. And it's a document by Spektrum meant for third-party developers and programmers who want to get their units to work with Spektrum receivers, whether it be the DSM-2 or the DSM-X. And it goes over how they work, and these output a 16-bit or byte data packet that reoccurs either every 11 milliseconds or every 22. And we can confirm that on the oscilloscope, which I will show in a little bit here. As it is right now, I like my little 150X for flying in the yard. I've got the Blade 130, which I could use instead, but I really like this little helicopter. And I don't really want to keep the JR radio. I was going to sell it when I was done all the conversions, but as it is now, I almost have to keep it if I want to keep flying this. But I'm going to show you a few neat things with these satellite RXs that some people might be interested in as far as the frame rate. Anyways, we'll get to that. Okay, so the first thing I'm going to show is binding the satellite receiver to using the 150 GRS by holding the bind button in and plugging in the battery. And this is I'm going to show this with the JR radio, so this is the actual working. This will work fine. The bind will work fine, and not only will the receiver bind properly to the radio, the receiver will then communicate with the 150 GRS. So as you can see, the receiver is in bind mode. The little light's flashing really fast. So I'm going to hold in my bind button as I power up the radio. And it's binding right now. Solid light, it's bound. Okay, and as you can see, everything's working on the helicopter. I'm able to throttle it up, and if we looked on the 150 GRS app in the application, in the transmitter screen, when I move the sticks, we'd also be able to see all the channels moving properly, meaning that the 150 GRS is recognizing the data packets coming out of this. Now what we're going to do now is actually see what frame rate that has bound at. Okay, so now we're looking at the signal. We're at 1 volt per division, so as you can see, it's the data signal is roughly 3 volts, and each one of these are one of the 16-bit data packets, and they're occurring at 11 milliseconds. So we know that the Align 150 GRS unit puts the Spektrum RXs into an 11 millisecond refresh rate. If you wanted to see just quickly what the data packets look like, you can't really see much on them. This is all binary, I imagine. When you move the sticks around, you can see these. Here, I'll just turn the intensity up. So as you move the sticks around, there's different, there's different packets that are, doing their on-off bit pulses and whatnot. Okay, so here's our Spektrum AR7000. We're just going to plug the little remote or satellite receiver into it. And we'll put the bind plug in. And we'll power it up with an external battery, hopefully. Okay, so as you can see, they're in bind mode. And we'll turn on our JR with the bind button held in. There we go, so both are bound. Now what we'll do is we'll unplug the satellite. So the satellite is now bound to the JR. And we will plug it back into our little T-Rex here. Again, we're still hooked up to the scope, so we can look at the refresh rate of the data packets. And we will plug this in. I should have turned the receiver or the transmitter on and off. That's the only reason that light's flashing. But as you can see, the 150 GRS is still communicating fine with the satellite. So back at the scope, let's turn the intensity up a bit. And now we're still at 5 milliseconds per division. So 5, 10, 15, 20, and 2 ticks, 22 milliseconds. And it refreshes again in another 22 milliseconds. So as you can see, it doesn't matter if the refresh rate of the data packets is at 11 or 22. The helicopter or the 150 GRS is still communicating fine. And again, if we zoom in on a data packet, it looks pretty much identical to what we saw before. Now we'll do the Horus with the Spektrum DM9 module, and you'll see it's not working at all. And we'll do the same exact bind procedures, the two methods. Here we're doing it with the Horus and the DM9. So we'll plug this in while we hold the bind button. So first we're going to bind through the helicopter. Little satellites in bind mode, lights flashing fast. Now what I'm going to do is I'm going to be holding in the DM9 module bind button on the back of the Horus as we power it up.
You turned me on. Switch warning. Normal mode. Throttle release.
Just watch that
high rates, rudder high.
Receiver. Okay, so receiver's bound. DM9 module is working. And nothing. No communication at all from the receiver to the 150 GRS. And I can confirm that if I open the app up. I'm not going to show that, but when you go into the app, when you go into the TX and the channel monitors, none of the channels are moving. I should mention also this little T-Rex, it is updated to the latest firmware, which is what, 1.1.1 I believe. I don't think there's been anything since, and that was back in early summer 2017. So that's binding it at 11 milliseconds, which we can look at on the scope here. This is the FR Sky DM9 module, and as you can see, the data packets were at 5 milliseconds per division on our time scale. So 5, 10, 1 tick, 11 milliseconds. And if we zoom in on a data packet, what are we at? 0.2 milliseconds here. So again, same kind of digital data packets that we saw before, but for whatever reason they're not communicating with the 150 GRS. So now we'll bind the receiver with the AR7000, so we'll be at the 22 milliseconds, and we'll see again it doesn't work. Okay, so just like before with the JR example, we've got the satellite or remote RX plugged into the AR7000. And we'll power it up. Okay, both are in bind mode. Get the Horus holding in the bind button again on the DM9 as we power it up.
You turn me on. Switch warning, normal mode, throttle release, high rates,
Okay,
rudder
so they're
high.
binding now. Okay, there we go. Both are bound now to the DM9 and the Horus. We'll just power the Horus off here.
Oh, nasty.
Okay, and get these out of the way. So now this is bound to the DM9 module in the Horus. We'll plug it in. And seeing that we bound with the AR7000, this is actually at a 22 millisecond refresh rate now for our data packets. So turn the Horus back on.
You turn me on. Switch warning, normal mode, throttle release, high rates, rudder high.
And we'll plug in the helicopter. Okay, solid light on our satellite showing that it's bound, but nothing. Nada. And if we look at the scope, okay, so what's our frame rate for our data packet refresh? Again, 5 milliseconds per division, 5, 10, 15, 20, 2 ticks, 22 milliseconds. So we're at 22 milliseconds, doesn't matter. If we zoom in on data packet, again, looks pretty much identical to what we've been seeing all along. And what else? Oh, one last thing in the radio. Let's just zoom out a bit here. I just want to show in the radio, just if anyone's curious, I do have the ppm frame rate for the external RF module at 22 milliseconds. So I'm stumped, folks. This is a big showstopper for me. If anyone wants to comment on the video here, if anyone's run into this before, and if anyone knows how to get the DM9 module communicating with the T-Rex 150X GRS, that would be interesting to know. If there's just no way to do it, that would also be interesting to know. Yeah, there's probably different module hacks I could do, but the whole reason I got the DM9 was so I wouldn't have any compatibility problems like this. Obviously, I am. If you want to comment, feel free, or if you want to contact me direct through my site, if you don't want to use YouTube, you can do that as well. I'll link to my site below, so you can use the contact page on it. Cheers, folks!